Good morning for those of you who are on the phone already. We'll just give it a couple seconds. I've got people getting signed in here. And we'll get started here. It's the 10 o'clock hour. I'm just going to give it, things are signing in quickly, so I'm just going to make sure we get as many people on the phone as possible before I get us kicked off here. This beautiful Thursday morning in West Michigan. I know some of you are coming to us from across the state and beyond, so welcome. And this morning our speaker was asking me if this was a Zoom background or real, so it's real. This is my backyard, so hopefully we don't have any unexpected noises besides that beautiful sound of the birds singing right now. Buenos dias. I see we've got some people already logging into the chat box. All right, I'm going to get us kicked off here. So welcome to the Healthy Building Series. This is our 6th webinar in a series that we launched in late April. And we are working to provide you the tools and resources that you need to get your businesses back open safely. I want to thank our sponsor for today's webinar, Hedrick, and just say a few words about Hedrick. So they are a local company here in West Michigan, and they are specializing in precision HVAC and critical power systems. They have over 30 on staff, and they provide engineering and hands-on operational support to their clients. You guys may be familiar with some of the products that they rep, Liebert, Marley, Mitsubishi, Armstrong, Weil-McLean, and Plasma Air, which we'll be talking about today. I want to point you to the chat box, or I'm sorry, the Q&A box, to log questions as we go along. Our speaker will answer those towards the end. We expect the presentation to last around 30 minutes, and then we'll get to those chat box, or I'm sorry, those Q&A questions. Feel free to use the chat box too. I'll monitor that. And so if you want to go to the next slide. So just to introduce myself, I'm doing all the talking. I'm Sherry Holman. I'm the Executive Director of the U.S. Green Building Council of West Michigan. And today we have Larry Sunshine with Plasma Air. And he says that is not a stage name. That is his real name. And so welcome, Larry. We're excited to hear about bipolar ionization. This is something that John Rumor was introduced to us during an indoor air quality webinar that we had about 2 weeks ago. And there was a lot of interest in bipolar ionization, including myself. So I'm excited about what you have to share with us today. So I will let you take it away, Larry.
Super. Thank you, Sherry. And guys, thank you to the USGBC West Michigan chapter for having me. Excited to present the deep dive into bipolar ionization. Yeah, there's a lot of questions about it. I mean, I've been involved in this business now for about 13 years. So I have a lot of answers. I don't pretend to have all the answers, but I have pretty much all of them. I'm hoping to be able to answer all your questions during the presentation, but feel free, shoot some of you sent some questions prior, which we'll get to. Sherry will ask those of me later, but send questions, and those are a great way to kind of interact together. So what's the agenda? Well, we're gonna first discuss indoor air. What's in the indoor air? Although we're learning in the last couple of months, we're learning what's in the indoor air, but what is it? What are those contaminants? Where do they come from? What is bipolar ionization, and where does it originate from? What is ionization? Where does it come from? Is it natural occurring? Is it artificial? We're going to go through all that. The positive effects of ions. Why do we want ions? Where do they come from? What is an ion? What do they do for us? How the technology takes advantage of ions. We'll look at some performance testing. And then I threw a couple of slides together about viral protection. The virus is, of course, the coronavirus, and we'll talk about what some issues are related to that and how ionization can potentially help with that. We'll look at some applications. We'll go through some products. We're not going to go through a million products, just kind of 1 or 2 slides on products. And then ASHRAE's IAQ procedure. Some of the early questions was about the procedure and how to save energy using the procedure. I actually had a whole bunch of slides on this, but in the interest of time, I took those out. But I will definitely spend a few minutes on that and how to do that and what's interesting about that. And then we'll compare ionization to other technologies, and then we'll have a Q&A session really towards the end. So why purify indoor air? Well, we ingest roughly a gallon of water per day and a gallon of food per day, roughly. Maybe some of us drink and eat a bit more than that, or maybe less, but we breathe 2,700 gallons, just to put things in perspective. And up until recently, we would ignore the indoor air, just assuming, well, it's clean, it's fresh. Well, it's not. The other important stuff is that, of course, we're spending not typically 90% of our time indoors. It's probably closer to 100 these days, maybe 99% of our time because of the pandemic. And unfortunately, indoor air is sometimes 10 times more contaminated than outdoor air. So we need to really address indoor air, and we're going to talk more about that. What's in the indoor air? Why should we be concerned? Well, I moved viruses up the list here to make it first. I've been making this presentation for over 10 years, and I guess thanks to the pandemic, people are becoming more and more aware of the indoor air quality and the contaminants that are in the indoor air. Of course, we have to worry about viruses now, bacteria, mold, VOCs, which is basically off-gassing, dust, pollen, pet dander, other particles, smoke particles, chemicals, and then of course, VOCs, PM 2.5 and other PM. You have PM 10, PM 2.5, and PM 1, and of course, odor. So lots of stuff in the indoor air. Most of them are not so good. Where did the bad stuff come from? Well, smoking, which I don't think we're doing too much of indoors, but cooking, any kind of combustion, if you have a wood stove, built off-gassing from building materials, human effluents, just breathing, perspiring, going to the bathroom, all that stuff creates gases, and bioeffluent, they call it. Stale air, cleaning chemicals, carpet and paint, again, off-gassing, pets create all kinds of contamination. So what is now that I've showed you all the scary stuff in the air, how do you solve that? Well, let's talk about bipolar ionization. What is that? Well, where does it come from? Well, if you climb up a mountain with an ion meter, which I've done a few times actually, and you measure ions, you're going to get roughly 1,000 to 1,200 ions per cubic centimeter. Cubic centimeter is about the volume of a thimble, pretty small, but so you're going to have roughly 1,000 ions per thimble if you think about it. As you get into lower elevations, rural, and then into small cities and large cities, the ion count goes down. Why is that? Why does the ion count? Well, first of all, where do the ions come from? Well, it's the sun's energy. The energy of the sun strips electrons from molecules. When you move electrons around, you create ions. And in another slide, I'm going to show you a little more detail on that. So you might look at this slide or this graph here and say, well, does the sun really discriminate against the cities? Of course not. It doesn't discriminate against anything. But what do we have in cities that we don't have way up in the mountains? Of course, we have pollution, right? We have cars, we have factories, we have industry, and the ions are being neutralized by the pollutants that are in the cities. Take this theory one step further inside buildings, and you have really bad ion levels inside buildings. Again, why? Well, number one, you don't have the sun shining in every room inside a building, plus you have pollutants inside a building. Off-gassing, paint, carpet, and human bioeffluents create all kinds of contaminants which neutralize any ions that may be present. So what we do as a technology is we pump ions inside the building to roughly equal what you're going to see up in the mountains, right? We replicate mountain elevation ion levels indoors. That's what we're trying to do. And when you get mountain elevation ion levels, you get better air quality. And what is that benefit of having these oxygen ions? Well, they cause particles to stick together. So bipolar ionization, right? Positive and negatively charged ions charge particles oppositely. Oppositely charged particles stick together. They're now, you might have 10, 20, 30, 50 little micron-sized particles clumping together, and now they're larger. Of course, if they're larger, they're heavier. When they're heavier, they'll fall out of the breathing zone. That will either fall to a surface or the floor, and again, we'll talk more about particles in a few minutes. It inhibits the growth of mold, virus, and bacteria. How does that happen? Well, the ion will attach to the cell wall and rob the cell of life-sustaining hydrogen, right? Oxygen wants to find hydrogen to create water. Of course, this is all microscopic, and so it steals the hydrogen from the cell. Again, we'll talk more about that later as well. Oxidizes gases. This technology is used in wastewater treatment plants. In fact, we have several in Michigan. Also, smoking casinos, garbage rooms, locker rooms, health clubs, hot yoga studios, any kind of odorous projects would work well using ionization. Breaks down VOCs. Not all VOCs, but a lot of VOCs. And we're going to talk a few minutes of what a VOC is. And then all these things relate to the symptoms of sick building syndrome. I don't know if you remember this, if you're old enough, like I am, but years ago during the oil embargo, oil crisis, buildings shut down their outside air dampers. We didn't have the energy to heat and cool outside air. So that created health problems inside buildings. People had scratchy throats and runny noses in their eyes. And that was basically all the contaminants building up inside the air. We weren't diluting them by bringing in fresh air. So all of these things relate to those symptoms, and we now have a way of solving that problem. And we're going to get through some of that in a few minutes. So I promised you a discussion on particles. This is very riveting information here, but so in a typical air sample, you might have 19.9 million particles. 19.6 million, 98.5% of all the particles in the air are less than 1 micron. A micron is very, very small. Another 1%, another 214,000 particles are between 1 and 3 microns. So unless you've got a HEPA filter in your system, which most of us don't, and most of us can't add a HEPA filter because of the added pressure drop, 99.5% of the particles, at least 99.5% of all the particles in the air are going right through your filter. So you might be wondering, why do we even bother with a filter? A MERV 8, a MERV 10, really not doing much for you, to be honest with you, except that it's catching the large particles, the 10, 20, 30 micron size particles. We joke in the industry, you know, sticks and leaves and rocks, the really, really big stuff. But it's the small stuff, as we're learning through this pandemic, it's the small droplets or the really super small particles that remain in the air. So let me jump to the next slide. This will make a little more sense to you guys. Well, 100 micron size particle takes about 8 seconds to settle 8 feet. All right, that's a large particle kind of falling out of the breathing zone quickly. A 10 micron size particle takes about 13.5 minutes, and a 1 micron size particle takes about 19 hours. Now, this testing was done in still air. We know the air is never still, right? You've got Coanda effect, you've got airflow, you've got laminar airflow, you've got people talking with your hands. So the air is never still in a building. There's a lot of air movement, air velocity. So basically anything 1 micron and smaller stays in the air forever. It literally is so small and so buoyant, it doesn't fall out of the air. Again, what's the problem with small particles? Well, small particles are typically the vehicle that transmit bacteria and virus from person to person. I've been saying this for 12 years. It finally took the pandemic and the experts. Now the whole world knows about small particles and why they're potentially dangerous for us. They stay in the air and we breathe that in. And unfortunately, if there's a virus cells on those, that's how oftentimes the virus is transmitted from person to person. So a bit on ionization, the actual technology. How do we make an ion? Let's dig into this a little bit, right? The title of this is a deep dive. I don't want to go too deep because I might lose some of you guys, but the cliff notes on how to make an ion is here. When we take a neutral oxygen molecule and when we ionize it, okay, when we impart a certain amount of energy to this molecule, we strip off an electron. That electron jumps onto another neutral oxygen molecule. So when you're neutral and you gain an electron, you become negative ion, right? And when you're neutral and you lose an electron, you become a positive ion. So this is how we make positive and negative ions. These ions then clump together with other oxygen molecules, creating an ionized clump, if you will. Just think about a positive and negatively charged ion. So this is the kind of, again, Reader's Digest version. There's a much more in-depth discussion about covalent bonding and satisfied outer shells and valence electrons, and I don't want to bore you with that stuff, but just understand, if you get anything out of this slide, we're not splitting an oxygen atom, because then that would create ozone. We are stripping an electron, creating negative and positive ions. That's the key takeaway from this slide here. What do we actually do in a building? What is the benefits to bipolar ionization? Well, I think we can categorize them into 4 different things. Number one, which we just talked about, we charge airborne particles, causing them to cluster together or agglomerate together. They either fall to the floor or they get caught by your filter. So your MERV 10 filter might act like a MERV 12 or a MERV 13. Okay, it will anecdotally, we have proof that will improve the efficacy of your filter. Number two, as bacteria and virus cells divide, the ions attach to them and rob them of life-sustaining hydrogen, and they're destroyed, killed, or deactivated, whatever word you want to use there. Odorous gases are oxidized. That's basically the ionized oxygen. We call it oxidation of the odors. And number four, VOCs, as I mentioned before, VOCs, volatile organic compound. It's basically off-gassing. The ions cause chemical reactions with the VOCs, breaking them down into less harmful VOCs. Not all VOCs, but a lot of VOCs. Okay, let's come to the next slide here. So it's kind of hard to prove. It's kind of hard to prove to people improved air quality. So we've come up with a couple of little demos or cute little videos here to show how the products work. So this is a small plexiglass box, which you can see. We are now pumping cigar smoke, but the cigar smoke could be cigarette smoke, could be particles, can be any kind of airborne dust, dander, any kind of airborne particles. It would work the same way. So we fill the container up with smoke, and there's a small little ion generator in the bottom of this. You can see we just pumped it up with smoke, turned the ion generator on, and we're going to watch it work. So what happens, again, that ion generator is creating millions of ions, causing the smoke particles to agglomerate or cluster together. Those are now falling out of the breathing zone inside the box. There is no fan, there is no filter, so nothing's being filtered here. This just proves that within about a minute or so, the airborne particles will disappear. You can start to see that they're disappearing now. And that little ionizer is the same guy that will kill bacteria, virus, neutralize VOCs. It's not just a particle agglomerator. In fact, I can introduce now, I just got the test report yesterday. The Spanish government did a test using that device on a surrogate for the coronavirus, and it showed a 99% kill rate on airborne coronavirus and an 80% reduction of surface kill of the coronavirus. So not only does it agglomerate particulate, as you can see right now, but it does a lot of other good things, including killing viruses. So you can see, folks, in about a minute or so that was gone. I have another quick video. This is much quicker. And you can see two plexiglass boxes. One has an ion generator, the other one doesn't. They both have a petri dish of water, and this is a 6-day time-lapse photography. And you can see the one without the ion generator gets nice and moldy, and the other one looks just fine. So again, couple of quick videos here, guys, to try to prove and show how the ionization technology actually works. Okay, so more testing. Well, we've done, this is just a highlight. We've probably have roughly 100 test results on different products and different pathogens. And again, not just my company, but our competitors also have plenty of testing. So please understand that ionization has been vetted and tested by lots and lots of worldwide organizations. It's not really a new technology. It's been around for decades, actually, and lots and lots of proof that the technology works. So we did some testing on VOCs and formaldehyde. I'll show you that in a minute. Particulate, I mentioned smoke, and actual mold spores. We did something on dust as well. Bacteria and viruses, MRSA, E. coli, I mentioned a surrogate for the coronavirus, influenza A, mold spores. So we're not going to go through all these, but we're going to go through some. So we hired Intertech. They're the largest lab in the world. And we asked them to prove the particle agglomeration. Look, the little video with the smoke particles and with the cigar, that shows that it's working, but we wanted kind of lab testing. So we asked Intertech to come up with a protocol to kind of prove this to folks. So what they did is they took dust. It was actually fine dust #2. You can actually buy different grades of dust on the internet, believe it or not. And they injected it into an environmental test chamber, roughly 10 feet by 10 feet by 8 feet tall. And they injected it, mixed it for 1 minute, and then measured the natural decay. In other words, what % of the particles fell out of the air naturally without any technology on in 15 minutes. And we knew that would be a small number. That ended up being 12.6% natural decay. They then cleaned the room out, They repeated the test. They injected there's small dust particles as well with the technology, the bipolar ionization technology on, and you can see here an 85.86% reduction in dust particles. We repeated the test with mold spores. The natural decay of the mold spores was 67%, and with the plasma air ionization on it was 91. Now you might, if you flip back to the other one, this one was 12.6 natural, this is 67. So why would the natural decay of the mold spores be so much higher than the natural decay of the fine dust? And when I say fine, guys, it was kind of like baby powder, really, really fine. The answer, of course, is that mold spores are larger, much larger than the fine dust. So they fell out of the air quicker, which again matches what the University of Minnesota showed in that slide a few slides ago. So when you do testing and it matches what other organizations do, you kind of feel good about your testing and your test results. So TVOCs, I mentioned, we started with about 40,000 roughly micrograms per cubic centimeter. And after an hour, there was roughly a 98.6% reduction. We did the same thing with formaldehyde, 95% reduction in formaldehyde. Of course, formaldehyde, folks, is a carcinogen. That's bad. You want to stay away from that. So we showed a really nice reduction on that. I'm not going to spend too much time on these, folks, but smoke particulate, we do casinos, and there's still plenty of smoking going on in casinos these days. So the lab actually, interestingly, broke down the smoke particles into different sizes, 0.3 microns, 0.5, 1, 2, and 5 microns. And you can see 73% reduction, 96, 97, 95, 95% reduction of the smoke particles. And then we have VOCs, or they're actually more aptly named PAH, polycyclic aromatic hydrocarbons. You can see we broke those down to undetectable levels within 30 minutes. So the PAH is benzopyrene, benzoanthracene, and dibenzoanthracene. These are carcinogenic chemicals that the tobacco company add to the cigarettes to give it that aroma, right? Polycyclic aromatic aroma, give it that smell that make it addicting. So too bad for them, but it is what it is. Okay, I added a few slides on viruses and viral protection. Again, too timely to not really do a deeper dive into viruses. So let's talk about this. We're all now experts on large droplets versus small droplets. So a large droplet, of course, happens when you cough or when you sneeze. Those particles, though, because they're larger and they're heavier, they will fall out of the breathing zone much quicker. I say here 5 feet, and that's where I think the 6-foot social distancing came from the CDC and the WHO and many, many other organizations. Why is that? Because again, the large droplets fall out of the air quickly. Unfortunately, it's the small droplets that don't. The small droplets, again, from the other slide, can stay airborne for hours and can travel hundreds of feet. When this thing first happened and they talked about 6 feet, I kind of told my friends and family that 6 feet is nowhere near enough. You have to be much further away from people. People stopped talking to me and hanging out with me because I was kind of scaring them too much. But it's not good, folks. You know, we know, and now the news, and there's lots of stories about, yeah, the 6 feet's probably not enough. Maybe it should be 10 or 20 or whatever. I saw Dr. Oz was on some show the other day. And he talked about talking, but just breathing and talking for sure creates these small particles. When you say Thursday, he kept saying, when you say Thursday, when you put your tongue up against the top of your teeth, you're spitting, to be honest with you. You're creating small droplets that stay airborne, again, for hours. So that's why we want to wear masks and we want to stay socially distant. And that's kind of the importance of that. So there's been proof for years, folks, that ionization kills airborne viruses. John Oxford has been doing testing for decades. He's a professor out of a London college, but also he worked as a doctor in the London hospital. He's done many tests to prove that ionization is effective on several viruses. Also in 2017, this Aerosol Science conducted a study on MS. So MS2 bacteriophage is the surrogate for the SARS-CoV-1. It's also the surrogate for the current SARS-CoV-2 virus. So there was some proof a few years ago that it killed the surrogate. And here's some other testing. Again, other viruses, not just coronavirus, folks, but measles, influenza A, H1N1, SARS-CoV, both 1 and 2. We talked about norovirus. This FIX 174 is a E. coli surrogate. So lots and lots of bad things, but proof that ionization kills these things to a very, very high efficiency. What happened to the system from a viral standpoint? Well, the ionization devices, depending on what you have, so there's actually two kinds of ionization products, and maybe now's a good time to talk about it. There's a tube style ionizer, and there's needlepoint. And I have some product photos in a few slides. I'll show it to you, but the tube style creates a plasma field around the tubes. So when bacteria and viruses go through that field, they're killed instantaneously. The needlepoint doesn't have that field, but the needlepoint makes millions and millions of ions. They're sent into the occupied space where they do their work, right? They attach particles, they kill viruses by robbing them of hydrogen. We talked about all that as well. So this is what happens in a system and how the system works. A, there's either a field, or B, there's either a needlepoint product that creates ions. This is a portable product. There's also portables out there that have a tube style plasma field. So the particles or the cells or whatever it may be get drawn into the system with the fan. Those particles or pathogens go across the plasma field. They're killed instantly, and then they're sent out back into the room in a much cleaner state. So UL, one of the questions that I got last night was about UL. Yes, all of our products are either UL or ETL listed for safety. Yes. And again, many of my competitors, many of the other vendors in this category also have products that are UL or ETL tested. I wouldn't trust a product that wasn't. I would just be a bit careful about that. But yes, everything is UL or ETL listed. And we use UL 867. That's the electronic air cleaner standard, kind of the standard that's made for us. And also 1995 kind of allows it to be installed in air handlers. All of our manufacturing facilities are audited quarterly by UL Intertech. They come and visit and make sure that we're doing all the right stuff here. Applications, basically everywhere, right? Everywhere from home, school, hospital, nursing home, daycares, and obviously casinos, all the way down to airplanes, wastewater treatment plants, airports. Basically, folks, anywhere where improved air quality would be a good thing is a potential application. And what we're now learning, folks, is that yes, everywhere, supermarkets, drugstores, everywhere, restaurants, everywhere where we go and where we want to go, we need to do something about cleaning the air. You know, I was interviewed by a magazine a week or so ago, and I think the quote that they took out of that was basically, improved or clean indoor air used to be viewed as a luxury. It's no longer a luxury. It's really now should be viewed as an essential. You really now must think about indoor air and how to deal with it, certainly during this pandemic, but also moving forward. Products, again, we're not going to spend too much time on this, but just want to show you the array, the wide array of different products. I mentioned portables before. These guys are small. This is about the size of a shoebox. This one gets mounted to the wall. This is a much larger portable that has on wheels. I think it's 175 pounds, much heavier, kind of wheel it around. These are used in operating rooms and operating theaters around the world. Yes, they have ceiling cassette that have built-in bipolar ionization devices. There's larger bars that would get mounted in an air handler at the cooling coil. There's smaller units that get mounted on ductwork. And then this little guy here, which you saw before in the video, this is a very versatile unit. Could get mounted in a PTAC, a fan coil unit, even a small rooftop unit, a VRF cassette, mini splits. This little guy goes in a lot of different places. So lots of different products for different applications. I just wanted to show one more slide on products. A lot of people ask, again, it's hard to prove improved air quality. So how do you do that? Well, one way you could do air quality testing. That gets expensive, and it's really hard to do air quality testing in an actual living, breathing building. So we have ion meters. We have 2 meters. One is a handheld ion meter that you can walk around with and measure the higher ion level, right? If you're getting 50, 75, 100 ions, something's not working. If you're getting that 1,000, 1,200, then you're fine. Or you can mount this ion sensor on a duct or even inside an air handler downstream of your ion generator. This ion sensor has a set of dry contacts that you can tie to your building automation system, so you can have your building ensuring that your ionization devices are working properly. Several of the questions before the presentation also talked about how can you save energy? Well, ASHRAE's IAQ procedure is a procedure that was created 30-something years ago by ASHRAE. It was adopted by the IMC, by the International Mechanical Code in 2006. And yes, the answer is yes. You can save not only energy in an existing building, but you can save tonnage, air conditioning tonnage, and heating equipment for new construction or retrofits. Yes, you can save a lot of money. I had probably a dozen slides on this. Again, I took it out just for the interest of time. But yes, you can utilize this procedure. And what it does is it reduces the amount of outside air. And when you do that, of course, you're saving energy. But what you must be able to prove is that the ionization will neutralize or kill the COCs, the contaminants of concern. That will allow you to reduce your outside air intake by up to 75%, maybe more 50 to 65 or 66% is kind of more normal. It can reduce HVAC equipment by upwards of 20%, maybe 15% is kind of more normal for new construction. And you can see 20, 25% energy savings by reducing your outside air. I didn't want to talk about this too much because ASHRAE is actually recommending increasing your outside air, right? The more we can dilute the pollutants and the virus cells inside the building, the better. Many of you can't increase your outside air a lot because your heating and cooling systems are not designed for that. So again, an ionization solution will help manage your viral load and the other pathogen load inside your buildings. But yes, so suffice it to say, there is this procedure we happen to be very good at. We have software that runs all the calculations for you. So yes, this can be done. We're quite good at it, and I'd be happy to talk about it on another venue here. So kind of my last slide here before we jump to the Q&A. Comparing ionization to other technologies. I'm sure a lot of you have heard of PCO and ozone generators. Without getting too deep into this, there's other technologies. Some of them are fine. I happen to think ionization is the best of the group, just from a cost standpoint, from an efficacy standpoint. No maintenance, almost everything else has maintenance required. So just from everything, from a holistic kind of TCO, total cost of ownership view, I think ionization is the best. Just a note on UV lights as well. I'm actually a fan of UV lights. I think they're good, but they're not great. Let me explain what I mean there. So UV lights shine on a coil and a drain pan and will keep biofilm or other bad stuff from growing on the coil. That's fantastic. We want to keep bad stuff out of buildings, and of course the airflow that blows that around the building, and that's not good. So UV lights do a great job there. But please understand that most cases, it will not kill an airborne virus. The reason is that virus is moving too quickly through the light. You'd have to do they call it an on-the-fly kill design with UV lights. You would need many UV lights or multiple lights, or you'd have to run them parallel in a ductwork, or have 8, 10, 12 feet long run of UV lights. So you have to really know how to do that in order to have your UV lights kill viruses. People just say, oh, I'll just slap a UV light on my coil and it's going to protect the building and kill all the viruses. And that's mostly not going to happen. So I just want to make a mention of other technologies and how ionization compares. Okay, I'm done with that, right on time. Sherry, I must admit. So guys, we're going to ask, Sherry's going to ask a bunch of questions. You guys can, I think you've been putting a couple into the Q&A. But Mark, just want to mention Mark Mearson from Hendrick Associates. Maybe you want to take a photo of this slide. He's our local rep, Plasmare. Of course, we're a manufacturer, we're an international manufacturer, but Mark is our local guy. He's excellent. He really understands the technology better than almost all of our reps. And that's his phone number and his email address. Again, maybe snap a photo with your phone so you guys can have that. So Sherry, yeah, fire away.
Sure, absolutely. Well, we have them coming in through the chat box, through the Q&A, and the ones that our attendees have sent beforehand. So lots of questions for you. And I just had a couple comments. That was great. I can see why your friends are not wanting to hang out with you anymore. And it's kind of funny because I've been telling my friends that I know the rule is 6 feet, but I'm personally more comfortable with 12.
Yeah.
So I guess I may have been on the right track there, that's maybe a little bit better. But I also am not too keen on being inside of buildings right now, kind of wanting to stay outside as much as possible.
Yeah.
But so hopefully some of these technologies are going to help us to, feel safer about being inside of buildings and sharing air with others. So yeah, let me go into a few of these questions. So I'm going to start with John. Our friend John at Tower Pinkster has been putting some into our chat box, and he says, is there a clear air delivery rate for bipolar ionization? And does BPI have any effect on final art if used in art galleries?
Okay, good question. So clean air delivery rate, CADR, that is more of it's from AHAM, AHAM. I think that's the American Home Appliance Manufacturers Association, or the Association of Home Appliances. It's really more of a residential type of rating. It's more of a rating of where if you have a filter, right? It's the rate at which you deliver what's defined as clean air. So it's hard to come up with that. In fact, the test is not designed for duct-mounted equipment. So that's one answer. And about fine art, yes, I would make sure that your ionization device does not create ozone for fine art. Ozone is kind of bad in higher levels, and lower levels it's kind of fine. But I mentioned earlier, there's two different kinds of ion generators, a tube style and needle point. The tube style may make a bit of ozone, lower than the 50 parts per billion that ASHRAE allows, but needle points essentially don't. So if you're going to use something in a fine art application, I would stay with the needle point. The tube styles are just a bit more industrial. We use the tube, so we make both. Plasma makes both the needle point and the tube style, so we'll tell you which one you should use when. There are some companies that only make needle point and other companies that only make tube style, so they're going to tell you that it'll work for everything, and I don't think that's fair all the time. So we use the tube style for, again, more industrial, wastewater treatment plants, smoking casinos, garbage rooms, kind of cannabis grow facilities. We've done a bunch of those as well. So I would keep to the more industrial on the tube style. And for other projects, more commercial projects, museums and such, I would stay with the needle point.
Great. Perry's asking, what's the maximum operating temperature of the needle point products if mounted in a gas-fired unit?
Yeah, I think it's 200 degrees for most manufacturers. The tubes would be a little more dicey because of the expansion and contraction in the glass tubes, but needle point is really, I would no problem using that with a gas furnace, which is going to be a bit higher temperature, maybe 100, 170, 100, 160, 170 degrees. Should be fine, no problem.
Frank Schumeister is asking if there's a rule of thumb for installing a portable unit in a 2,500 square foot office and the energy use that goes along with that.
Yeah, the energy use is very low, but from a rule of thumb, all of the portables will have a square footage rating. So some of the ones that I showed, one had a 200 square feet, that really small shoebox one. The slightly larger one, it's called the NV900. That'll do 900 square feet. So, and the larger one, of course, it's a bit larger. So the 900 square feet, yeah, you might need 3 of those. Let's say for 2,500 square feet. If it was an open room, one large open room, you can get away with 3 of them. If it's multiple smaller rooms, it might be a combination of the portables. You might want the little 200 square foot guy in a couple of rooms, and then maybe the larger ones for a larger area. So yeah, they all have a rating on it. They'll be rated for square footage, not necessarily CFM, but they'll be rated for a square footage, and it will give you a corresponding air change rate per square footage, assuming like an 8 or a 9 foot ceiling. So it might say, yeah, 900 square feet at 2 air changes or 3 air changes. You have to have both of those numbers.
So is personally kind of thinking this through, like, is there a rule of thumb on kind of a price per square foot for this technology? Because originally when we talked about this in the Tower Pinkster webinar, I know that and I hope John doesn't mind me saying this, and I assume he won't because he did say it in his webinar, that they were at about $80 per employee. Now, I'm not exactly sure how many employees are at Tower Pinkster, and I'm also wondering if they had to pay for installation, given what they do. So I don't know if there is a rule of thumb, but one of the things that I'm learning about this is it seems like a pretty inexpensive technology.
Yeah,
especially for what it does, right? When we think about increasing outdoor air, doing this instead. John just said they have 150 employees, and it included, let's see what he says here. And that did include their installation costs. So, I mean, that seems like a small price to pay when we're looking at the potential of a virus outbreak or something. And you know, we've always had, well, we have our highest cost in companies is our staff, right? Yeah. And now, and that was true before, now we have this potential that somebody could be out for 2 to 4 weeks, or possibly even just someone who is exposed being out for 2 weeks. So, I mean, that's a serious, you know, number one, sick pay or whatever the organization is providing, but just that reduction in their work, you know, their efficiency is a lot to think about, and kind of puts a new piece of math, for lack of better terms, into a return on investment conversation.
Yeah, metric. So I think John's quote, and I'm going to answer your question actually in a second. But I think John's $80 per person. I think his point was it is very inexpensive. If you lose one employee for one day, it's more than $80. Forget about a week or 2 weeks, or God forbid if they get this virus. It's a very, very small price. I think ionization is really growing. For sure over the last 10 years, but really exploding now. I mean, our business, dare I say, is up triple now from what it was just a year ago. So busy, really busy these days, which is a great problem to have. But I think it's because it does a lot. It kills a lot of bad stuff. It improves air quality dramatically, and it's not that expensive. So to answer your question, and my reps around the world right now, if they're listening, they're cringing, right, Larry? Larry, do not give a cost. Don't you dare. I'm going to do it anyway.
It can be really ballparky, right?
Yeah. So why don't we say, again, installed cost, roughly, I would say 50 to 60 cents per square foot, plus and minus, 10 cents. If you got a really efficient, if our units match your air handlers kind of perfectly, you could be on the lower end. If it's not perfect, then you have to kind of oversize some stuff, whatever. It might be on the higher end, but you figure 50 to 60 cents per square foot, roughly, for the in-duct solution. The portables will most likely be more expensive because it's a more concentrated solution. Although some of our customers are putting the bipolar or the plasma air devices in the air handler to kind of treat the whole building, and then they're spot treating really high traffic areas with some of the portables, the lobby, the elevator areas, the entry lobby, maybe the conference rooms. They might be putting a portable, or a little cafeteria. They might be kind of double treating it just because of what we're going through right now. But that's kind of a cost, Sherry, that I'm willing to share with the group here.
Great, thanks for that. So Nathaniel's asking, would BPI help with airborne non-polar oils, like aerosolized cooking oils?
Wow. If the droplets are small enough, yeah, there is some proof that almost any, so people say droplets, you can almost use the word particle, even though when people hear particle, they think it's a solid, but really, really small droplets can also be kind of referred to as particles. So there is proof that really, really fine droplets would be improved by using ionization. If it's larger droplets, of course, it's going to fall out of the ground anyway. But yeah, the answer is yes on that.
Cool. He also asked, if the ROS are reactive enough to reduce virus population through hydrogen-involved reactions, how does that not aggregate the sensitive, or aggregate, I wonder if he means aggravate, the sensitive mucous membranes of personal airways?
So first of all, he mentioned ROS, reactive oxygen species. So you only get ROS when you have ozone present. So again, a vast majority of our sales use the needlepoint technology, which essentially does not make ozone. So you're only going to get ROS when you have ozone present. And yes, when you Google or do a search on ionization, you're going to see ozone, because older technologies from decades ago made some ozone. Again, most of them lower than the 50 parts per billion, but again, the needlepoint doesn't really make any ozone, so you're not going to have ROS.
Cool. Let me take one of our prior questions. Does bipolar ionization generate secondary contaminants such as ozone or CO2?
Right. So that I just answered that. So.
Sorry.
Yeah.
Maybe you put it up twice.
Okay. Yeah, I did. I actually did that. So yeah, we just talked about that. So no, the needle point technology does not create ozone, and therefore there aren't secondary byproducts. But again, whatever technology or whatever company that you're using, make sure it doesn't produce ozone.
Okay. So there's two that are talking about testing. One of them's asking about you mentioned that there was just a study that was conducted and that you just released and were able to talk about.
Yeah.
Wondering if you could dig a little deeper into that. And then also the question has been posed as how bipolar ionization has been tested specifically against the COVID-19 virus.
Yeah.
And are there any third-party sources that you could name?
Yeah, and yes, and so the answer to both of those questions is really the same answer. So yes, just yesterday, I received the test report from the government of Spain. Of course, Spain was hit very hard by this virus. They were one of the early on, and lots of people unfortunately died because of that. So they are very interested in figuring out how to cure that or solve it, I should say, avoid it. So they tested one of our devices, that little 600, that little black thing that you saw in both videos. It was an interesting story. They converted a hotel into a temporary hospital because they were running out of hospital rooms, and they wanted to test the technology in the room just to see what it would do on the virus. So they set up a kind of an intricate test. There was PhDs involved, and the Minister of Health, and all kinds of organizations that were involved and signed off on it. And yes, they tested both airborne, a surrogate for the coronavirus, both airborne and surface, and it did show a 99%, which is a log 2 kill rate for airborne coronavirus surrogate, and 80% surface kill rate for the surrogate as well. So really fantastic testing. I just got it. We haven't really released it yet officially, but we'll probably write a press release and we'll get it out to all of our reps in the coming days so they can distribute it out to their customer base. But really exciting. So yes, that's number one. Number two is that we have several of our other products in with a lab, one of the leading US labs, for more coronavirus surrogate testing, and that's actually going to happen next week. We put our stuff in about 8 weeks ago, but they're swamped, the labs, on doing testing. So our testing will happen next week, and we should get some results within a few weeks after that. So very exciting for that as well. But look, the good news on this is that good news and bad news on this virus. It's kind of easy to kill this virus. The bad news is it's very contagious. You know, it's if it was hard to kill and very contagious, wow, we'd have a big problem on our hands, even bigger than what we have now. But there are products out there that kill this. We're one of the first to actually have a test that shows that it kills, again, a surrogate for coronavirus. So we're proud of that. And again, we'll probably release that in the next few days so the industry can get that report.
That's awesome.
Yeah.
Nathaniel's asking about for the test results shown, are the ionized particle levels reasonably comparative to normal installation's full-time levels?
Very, very good question. So I've seen lots of testing, and we actually have some as well, where there's a small box and they pump in zillions of ions and you're kind of cheating a little bit. This test was not. This was in a real room. It was in a hotel room. And the ion levels that they shot for, that they aimed for, was roughly 1,000 ions per cubic centimeter, which is what we recommend will improve air quality. So this was a more representative test of a kind of a real live application, not in a tiny little container where you're flooding the container with a much higher ion level. So yeah, really a legitimate test and one that would represent a kind of a real life application.
Cool. Chris is asking if you can comment briefly on the outdoor air reduction against increased CO2.
Yes. So
yeah, go ahead.
Yeah, boy, I know a lot about that as well. So when you use ASHRAE's IAQ procedure to reduce your outside air, you're going to increase your CO2. There's no way around that. CO2 typically is held around 1,000 to 1,100 ppm. When you reduce your outside air, you're going to get higher levels of CO2, roughly maybe 13, 14, 1,500 ppm. However, OSHA's 8-hour regulatory level is 5,000 ppm. So going from 1100 to 1500, not a big deal when the maximum, the 8-hour maximum is 5,000. So nothing to worry about there. There were some studies, I think actually Harvard put out a study and some other folks to show that increased CO2 levels, maybe to 2,000 to 3,000 ppm, there was a reduced cognitive function. But then there's also several tests by leading worldwide organizations. I think University of Denmark did one, showing that at higher CO2 levels, there was not a reduced cognitive function. So way more testing has to be done than that. So yeah, increasing CO2 from 1100 to 1500 is not going to do anything. You're not going to get reduced. Again, there's testing that shows that there's no reduced cognitive function. So yes, reducing your outside air, slightly increasing your CO2, not an issue, save tons of energy. And improve air quality, by the way. You know, a lot of people do it for energy, but why not kill viruses and reduce odors, et cetera, at the same time? Kind of a no-brainer.
It is, and I think that you know, with ASHRAE saying open up the outside air right now, of course, from most people's perspective, and certainly from ours as a nonprofit that's promoting energy efficiency, and we run the Michigan Battle of the Buildings, where we're, you know, trying to help people reduce energy. So it's cringeworthy for us to say, open those vents and let the outdoor air in, you know, and so
yeah, Sherry, very, very good point, of course. What some of our customers are saying is that they're applying our technology to improve air quality, kill viruses, et cetera, but that when this is all over, you know, a year or two from now, hopefully maybe shorter than that, sooner than that, they'll use the same installed equipment to capitalize on the ASHRAE's IAQ procedure to save energy. And maybe it'll take them, depending on if it's an office building, maybe it is 3, 4, 5 years to pay for that equipment, but eventually you get the equipment for free. Buy it now to kill viruses and then utilize the procedure next year or whatever to save energy and eventually pay for the equipment. Mm-hmm. Yeah.
So we've been told that bipolar ionization changes particles in the air. The particles then find opposing charges and are attracted to them. This means that the charged particles will either plate out on opposite charged things, such as people or the environment, such as furniture or TV. Yeah. Is this logic accurate?
The logic is accurate, but we're thinking about something else. So great question, and luckily I have a great answer. So what the question is referring to is single pole technology, meaning negative or positive ions. So when you create negative ions only, you're going to charge particles negatively only, and then those negatively charged particles, yes, are going to go stick to things in the room that are positively charged, like your computer screen or person or walls or what have you. That is called plating out. But because the technology is bipolar, right? The technology, the summary of the title of this is, right, a deep dive into bipolar ionization technology. Because you have both poles, positive and negative, they stick to each other, like we talked about, instead of plating out on things inside the space.
Okay, I got a good one here, and hopefully I don't think I answered this one yet. I had a pen and I was marking off my questions, but I think it blew away.
Okay.
What is the additional percentage reduction of circulating particles when BPI is installed? Basically trying to see if improved safety is worth the higher installation cost.
Wow, the increased reduction of particles, is that what that question was?
What is the additional percentage reduction of circulating particles when BPI is installed?
I mean, I mean, that's kind of a project by project basis, but you know, like I mentioned before, there is proof of reducing airborne particles and then having them either fall out of the breathing zone or be caught by the filter. We do not have a test. We have anecdotal proof. We also have statements from building owners that their filters are dirtier. You know, if you change a filter by calendar, you know, every quarter, let's say, or every 2 months, whatever it might be, they're telling us that they're loaded more. There's more dirt and fuzz and dust being collected by the filter, therefore showing that the ionization is doing something. These are people that have been changing filters for years, and they've told us, hey, We didn't realize how clean the filters we've been changing until we added an ionization system. So anecdotally, we have proof. I don't really have a percentage. Plus, it would need to be kind of calculated on a building by building, space by space basis. And you'd also have to know what particle levels you're starting with. And a lot of particles come into a building from the outside air. So we would need to know the outside air percentage. It's a much more complicated answer, but anecdotally, we're going to improve the reduction of particles, and they're going to be caught by the filter.
Yeah. Okay. Regarding uses of outside ductwork, and an example being a reach-in or passing between people, such as bank tellers. Can you address the availability of air curtains made up of bipolar ionized air and the volume of air required?
Yeah, we have been approached by 2 air curtain people, one more recently. So we're in discussions with folks. But it's really a great idea. As you enter from one space to another, it'd be nice to kind of have a shower of ions, if you will. I don't know if they make them that small where you can kind of have it with a bank teller. Certainly I'd be wearing a mask and I'd be wearing gloves if you're going to go near people or touch things that other people are touching. Yeah, an air curtain is an ideal. Again, we don't have an OEM relationship yet with someone, but we're talking to someone now. And that might be something that we have. Yeah. So if you know an air curtain company, for sure, have them reach out to an ionization partner. And yeah, we should do that. It's actually a really good idea.
Yeah, it sounds, I mean, from my perspective, it certainly sounds a lot better than what we're seeing in some other countries where we're actually seeing them, shower people and disinfect. I don't even know what they're spraying on people, but the thought of that happening is, yeah, I'm not excited about that. If, for anyone to start doing that here.
Well, I actually saw that as well. That's somewhere in Asia. I don't know if it was Hong Kong or Taiwan or something, but yeah, they had this kind of little booth or something, a little phone booth that you kind of walk through, and it would roll. And guys, Asia has been using ions for decades. They're a good 10 to 20 years ahead of us as far as using ionization is concerned. So I wouldn't be shocked if it was this air curtain idea that this question had about just blowing tremendous amounts of ionized air for a few seconds on the person. But yes, they were using some kind of technology. And again, I wouldn't be surprised if it was ionization.
Okay, we're going to take our last question with just a few minutes left. Perry Houseman with Tower says, what with the tube type plasma generator technology, do ions enter the occupied space, or is it that only the needle point? And the follow-up is, does needlepoint technology require a fan for distribution of ions, or will they diffuse on their own without a fan?
Okay. First question, yes, I think I actually skipped that. So great job of catching me on that. So the tube style has a plasma field around the tubes, but it also creates ions, absolutely creates ions and goes into the space. So yes, if I wasn't clear before, shame on me. The needle point, of course, only makes ions, and those are delivered into the space as well, doing all the things that we talked about in the presentation. The second question was, do you need a fan? Yeah, I mean, look, if you put an ion generator on a desk, it'll create ions. They'll kind of ooze around. Just natural wind currents in a room would kind of spread it around. But there's no question a centrally mounted ionizer, needlepoint ionizer in a central duct system is a much better way of delivering ions. You're going to get a much fuller solution than just putting an ion generator on a desk or on a table or whatever, for sure. I mean, could you do it? Yes, but they're not designed to do that. So they are designed to be mounted in a duct system with a fan, for sure.
Awesome. Frank is wondering if Plasma Air is a public company. Perhaps he'd like to buy some stock.
We are not public. We are private. Doesn't mean you can't buy stock in the company, but no, it'll be harder to do that. But we are not public. No.
Great. Well, if you'll advance to the next slide. I just want to thank you so much, Larry. This has been a great conversation. I've learned a lot. I hope all of you have learned a lot or got the questions answered. Please reach out to, your local wholesale house or your local contractor if you'd like to know more. Of course, Mark at Hedrick is available, and hopefully you got a snap of that of that screen so that you can contact him across Michigan and in Indiana they're servicing. I want to thank Hedrick again for supporting us. We're not having live events anymore, so things are a little bit different for a nonprofit. So we really thank him supporting the webinar. And if you'd like to support a webinar in the future, happy to have you. Very reasonably priced at $350. And I want to thank our chapter sponsors, Consumers DTE, the Michigan Department of Environment, Great Lakes and Energy, Eagle, and the Wege Foundation. Our webinar next week is addressing the healthy zone of humidity, and we'll learn what role the humidity does play in aerolizing pathogens, and also the benefits and the pitfalls of carefully controlling your humidity. There is a survey that will be up on your screen right after this, and you can answer that survey. And we will also send you a link to the presentation, a link to the recording, and information to sign up for the next webinar. So thank you, Larry. Enjoy your day. I believe you said you were in New York?
I am in New York, so I don't go out too much. Actually, I'm in San Francisco. That's the view outside.
Right.
No, I'm just kidding. I am, but thank you for having me, Sherry. It was really a pleasure and my honor to do this. I hope I was able to kind of educate folks on it, and yeah, it was really great. So thank you again for having me.
Thank you. See you later.
All right. Bye, guys.
Bye, everyone.